Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discussing the topic is Amplitude Modulation and Modulation Index. Amplitude Modulation and Modulation Index. Going to the first topic, Amplitude Modulation. The amplitude modulation, before going to defining of the amplitude modulation, to define the modulation definitely need two signals. One is message signal and the second one is carrier signal. The message signal is a low frequency signal and the carrier signal is a high frequency signal. Here the message signal is a low frequency signal. How it is represented means, the first signal, remember this is the message signal, I am taking this is M of t, message signal. It is a low frequency signal. Next one, second signal, high frequency signal, it is called as a carrier signal. This is the carrier signal, I am representing C of t. What is the definition of modulation? The process of high frequency carrier signal is varied according to instantaneous values of message signal. This is called as modulation. Then the first type of analog modulation technique is amplitude modulation. Here in the definition of modulation we are taking the word instantaneous. Instantaneous means either amplitude is varying, either frequency is varying and phase is varying. With respect to that amplitude or frequency or phase of the carrier, you are defining the type of modulation. Then going to the first one, under analog modulation techniques, the first modulation is amplitude modulation. What is the definition of amplitude modulation? Observe here, the amplitude of, remember very important, the amplitude of the carrier signal is varies in accordance with the instantaneous amplitude of the message signal. That means the carrier amplitude is varying with respect to message signal amplitudes, amplitude of the message signal. That means only the amplitudes are varying. The carrier amplitude, for example, the carrier amplitude, here I am taking, this is the carrier amplitude. This carrier amplitude is varying according to amplitude. For example, this is the amplitude of the message signal. Then the amplitude of the carrier is varied according to the message signal. That means the inner wave should be a carrier signal. It is varying with respect to message signal amplitudes. That's why it is called as amplitude modulation. Observe here again, the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. That's why here I am taking the message signal M of t and carrier signal C of t. The message signal amplitude should be AM. AM is message signal amplitude, and C of t, in this case the carrier amplitude is AC, that is equal to carrier signal amplitude. As per the definition of amplitude modulation, the carrier signal amplitude, what is the carrier signal amplitude here? AC is the carrier signal amplitude, is varying in accordance with the instantaneous amplitude of modulating signal. That means observe here, this AC is varying with AM. AC is varying with AM. Then I am getting the AM signal, nothing but AM modulated wave. When I am combining this message signal and then carrier signal, then I got this waveform. That means here, observe here, this is the message signal our low frequency signal, our information signal, it is also called as baseband signal. Then the amplitude should be AM, and here as per the definition, the carrier amplitudes varies accordance with amplitude of the message. This is the carrier amplitude varies with MSG, message signal amplitude. This is also, that's why the amplitude of carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. This is called as amplitude modulation. Then observe here, first of all, AM modulation and demodulation. What is this? Here I am, before modulator, I am taking message signal. After modulator, here I am getting like the carrier signal is varies amplitude with the message signal amplitudes. That means this is the message signal. Modulating signal is also called as message signal, baseband signal, information signal, whatever. The modulating signal, it is, I am applying the modulator. Here I am taking the modulator with the help of oscillator, carrier signal. The carrier is a high frequency signal. The maximum amplitude is AC, and this is amplitude in y-axis. In the x-axis I am taking time period. Here also in y-axis it is amplitude, x-axis time period, and it is the maximum amplitude, that should be AM. That means the modulator block, I am giving the input signals as one is information source, nothing but this is information signal, and modulating signal it is also called as. The next one is carrier signal. The carrier signal is a high frequency signal. That's why the time gap between the cycles is very less, and it is a low frequency signal. The time gap between the cycles are more, and both the signals I am giving to the modulator block. What happens as per the definition of the modulation? The high frequency carrier signal, otherwise the high frequency carrier amplitudes varying with respect to the amplitudes of the message signal, then I got the modulated signal. This modulated signal is AM modulated signal, nothing but amplitude, because only amplitude is varying, no frequency, no phase. Okay, that's why it is called as a amplitude modulation. Then this amplitude modulated signal is given to the demodulator block. What is that? Exactly, the modulation opposite operation is demodulation. Nothing but the input of the demodulator is the AM modulated signal is given to the demodulator. Then the output of the demodulator should be what the information you are transmitting from the modulator, the low frequency signal, nothing but here this is exactly what I am applying at the input side, nothing but message signal. This process, entire process is called as AM modulation and demodulation. That means in the modulation what the things are happened, and the demodulation what the things are happened. Simply observe here, I am giving at the modulation side message signal and carrier signal, both the signals are applying to the modulator block. Then the output of the modulator should be AM modulated signal, because only amplitude is varying. As per the definition, it is known as amplitude modulated signal. Then I am giving this as input for the demodulator block. Then the output of the demodulator should be original signal with frequency FM. Original signal. Therefore, this is complete AM operation. Mathematically, I am explaining clearly one by one. The amplitude modulation, taking the modulation means taking the two signals, one is message signal and carrier signal. Here I am taking the first one is carrier signal. Mathematically, I am representing the carrier signal C of t is equal to AC cos omega ct. C of t is equal to AC cos omega ct. What is C of t? AC cos omega ct means AC is amplitude of carrier signal, maximum amplitude of the carrier signal, and omega, nothing here, AC is maximum amplitude of the carrier signal, and omega C is 2 pi fc, nothing but frequency of the carrier signal. Graphically, the carrier signal should be like this, because the frequency is inversely proportional to time period. Once the time period is very less, means the frequency is more. That's why for high frequency signal, we are taking the signal representation should be like this. And go for the next one is information signal. It is also called as modulating signal. It is also called as baseband signal. Mathematically, it is given as m of t is equal to am cos omega mt. Similarly, am is maximum amplitude of the baseband signal, and omega m is 2 pi fm. It is frequency of the message signal. That means this is the representation of the information or modulating signal. Therefore, for amplitude modulation we are doing means definitely we are taking message signal and then carrier signal. Mathematically, I am taking message signal m of t is equal to am cos omega mt, and carrier signal is equal to c of t is equal to ac cos omega ct. Then observe here, when you are combining both the signals, nothing but as per the definition of the amplitude modulation. One more time I am revising the definition. The amplitude of the carrier signal. What is the amplitude of the carrier signal? AC is varying according to instantaneous values of the message signal. That's why observe here, the standard equation for amplitude modulated signal is S of t or y of t is equal to AC plus am cos omega mt into cos omega ct. What is the meaning here? This is entire carrier signal is varying with respect to message signal amplitudes. Therefore, that's why AC plus am cos omega mt into cos omega ct. This is the standard form of amplitude modulated signal. Observe here, the two signals are there. That means, for example, if you take am cos omega mt, this is the message signal, and AC cos omega ct, this is carrier signal. Therefore, m of t combined with c of t, that is equal to s of t or y of t. That should be as per the definition of amplitude modulation. The carrier amplitudes, that's why AC cos omega ct, this is frequency of the carrier, and this is amplitude. Therefore, AC amplitude is varying amplitude of the message signal. That's why the standard equation I am writing AC plus am cos omega mt cos omega ct. Then here I am taking the common factor as AC. Then observe here, 1 plus am by AC cos omega mt into cos omega ct. I am taking only common factor is AC. Therefore, if you write the AC should be outside. That means AC 1 plus, here am is there is no AC, that's why am by AC cos omega mt. Cos omega mt already is there, and cos omega ct. Cos omega ct. That's why the equation S of t or y of t is equal to AC into 1 plus am by AC cos omega mt into cos omega ct. What is am? AM is the maximum amplitude of the message signal, and what is AC? Maximum amplitude of the carrier signal. Therefore, it is a factor. AM by AC, that is equal to, I am taking mu or m, it is called as modulation index. What it is known as? It is called as modulation index. The maximum amplitude message signal or the maximum amplitude of the carrier signal, when you are taking the ratio between those two signals, then it is known as modulation index. Very important factor when you defining the modulation amplitude level or a frequency point of view or a phase point of view. The modulation index is an important parameter, because once AM is equal to AC, what type of waveform we are getting? That means when the carrier amplitude is equal to message signal amplitude. Otherwise, if carrier amplitude is greater than message signal amplitude and if the carrier amplitude is less than message signal amplitude, what it is known as? Before understanding those points, the definition of the modulation index is very important. Then, what is modulation index? Simply, the modulation index is the ratio of the amplitude of the message signal and the carrier signal. Amplitude of the message signal, it is AM, and amplitude of the carrier signal, it is AC. That means mu or MARM is equal to AM by AC, that is known as modulation index. What is the definition? The ratio of modulation index is the ratio of the amplitude of the message signal and the carrier signal. It is known as modulation index. Then it is very easy to find the value of modulation index when the amplitudes of the message signal and the carrier signals you know. That means, for example, AM is equal to 4 volts, AC is equal to 4 volts. Then mu or M is equal to AM by AC, that is equal to 4 volts by 4 volts, that is equal to 1 volt. Otherwise, AM is equal to AC. AM is equal to AC. Then, for example, AM value is 5 volts, AC value is 6 volts. Nothing but mu is equal to AM by AC, nothing but AC is greater than AM. Likely, AC is less than AM. For example, if you take AM is equal to 4 volts and AC is equal to 3 volts. And AM is equal to AC, that is what type of mod? That means once you know the values of nothing but amplitude values of the message signal and carrier signal, then it is very easy to find the modulation index. Then, what are the advantages and disadvantages of amplitude modulation? Observe here, the advantages of amplitude modulation is, it is the simplest modulation technique because only the amplitude is varying with respect to carrier. Here, no variation in the frequency, no variations in the phase. Therefore, only amplitudes. It is very easy to find or identify, to observe the amplitude levels of the modulated signal, nothing but a generated AM wave. That's why it is the simplest modulation technique. The next one is, demodulating the modulated wave is easy because the input of the demodulator should be AM modulated signal, then the output of the demodulator should be exactly what the information we are sending, that is nothing but a message signal. That's why the demodulating the modulated wave is easy. How we can set means, once we observe the generation methods and the demodulation methods, nothing but generation methods means modulation techniques of the AM signals, and the demodulation techniques of the AM signals, the generation of the waves, particularly AM modulation and AM demodulation, the operation and understanding is very easy. In the coming sessions, one by one we will learn with respect to the diagrams. Once we are applying the message signal as input and the carrier signal as the input to the modulated circuit, then the output signal should be AM signal. AM signal. That signal is given to the demodulator block. Then the output should be what low frequency signal we are applying at the input side, the same signal we are observing at the output side. That's why the modulation and the demodulation processes are easy in amplitude modulation. And important is, it is a low cost technique, easily understandable, and it is a low cost technique. The components and everything should be available, and designing is easy, and it is a low cost technique. And what are the disadvantages of amplitude modulation? The first point clearly explains high signal attenuation due to noise. The signal strength should be less. That means we are applying the input signal should be a low frequency signal. Low frequency signal means we are applying the signal should be audio ranges of signals, for example in terms of hertz and kilohertz. That means Once you are transmitting this low frequencies to signal into the AM transmitter or AM modulator, then automatically due to the processing, the signal strength is very less. That's why the noise is easily added. The noise is easily added to the original signal means definitely it is called as a attenuated signal. Therefore, in the AM modulation scheme, we are observing high signal attenuation. This is one of the drawback, one of the main disadvantage in amplitude modulation. Next one, it provides low efficiency because the first point is related here, disadvantage. What is that? Attenuation. Attenuation means it is a loss. For example, if I apply the input side should be 20 kHz signal to the input side, but we are getting output should be 18 kHz only. How much signal we are getting here? 2 kHz signal should be we are losing here. That means 2 kHz signal is losing means some information we are not getting exactly. Automatically what is that? The efficiency should be less. That is one more drawback in the case of amplitude modulation. Okay, that means what are the disadvantages? The first one is high signal attenuation due to noise, and the second one is it provides low efficiency. This is the disadvantages of amplitude modulation. Then what the topics were covered today's lecture means, what is amplitude modulation? We discuss about amplitude modulation, nothing but the standard AM wave. In the case of standard AM wave, we are observing the modulation index, nothing but mu or m, here S of t or y of t. We learned these two techniques, and in the next topic we covered the modulation index. Already in this case modulation index is covered, but only definition we are covered. But in this case modulation index, if mu is greater than 1, mu is equal to 1, mu is less than 1, what type of waveforms we are observing? Once it reaches to the zero level, the amplitude levels are reaches to zero level, then what it is known as? That is called as mu is greater than 1, mu is equal to 1, and mu is less than 1. These things can be covered in the next lecture. And AM generation methods. In this lecture we discuss what is amplitude modulation, what is the standard of AM, and the representation of the AM waveform, nothing but modulated signal waveform. In the coming sessions we are discussing about what methods we are using to generate amplitude modulated signals. Thank you very much.